core in your work, and this is probably the thing that most affected my thinking early on, was the concept of thinking about and measuring critically something you call the cost of delay.
Yep.
So can you spend a little bit, because most of our listeners perhaps have not met you, talk to us a little bit about cost of delay. And I know in our experience, it was shocking when we started to think about that, its impact, but also how it drove our thought process in how we approach design decisions.
Okay. So a lot of times when I use cost of delay, I'm using it in a very sort of well-defined, narrow way. A lot of people will take that label and hang it on a bunch of other things.
Right.
But in my world, the way we think of cost of delay is we say, if something happens on schedule, how much money do I make over the life of the product if I do that job on time? And how much money and then I also calculate how much money I make over the life of the product if I do that job 60 days late.
Right.
And the difference between those numbers is the cost of being 60 days late.
Right.
And so and that conceptual analysis, it's the difference between something happening on time versus at a later time, can be applied in a vast array of things. Like for example, a lot of times in production processes that have a deadline where, Boeing has to ship a plane on a certain date and things like that. And I'd work with aerospace suppliers, and they would say, well, what's the cost of delay on a product that is never late? We make a hydraulic cylinder for Boeing. We will do anything in the world possible to prevent delivering it late.
Right.
I say, okay, so that event is never going to happen and things like that. Why don't we look at some of the upstream milestones in your program and ask the same question? Your plan is to have a release to manufacturing 4 months prior to delivering the product to Boeing and things like that. What's really happening is you're late releasing it to manufacturing, and instead of having 16 weeks, they have 14 weeks or 12 weeks or 10 weeks. And then you say, okay, so when we slip that release to manufacturing, what happens in manufacturing? Are there any costs that appear that would not have been there if we had done it on time? And the answer is, then we have to start expediting in material.
Yep.
We don't have enough time to do the layout designs for the factory floor. We don't have enough time to do our fixtures and tooling and things like that.
Quality goes down.
We have we have rework. You can see in the work orders that we have variances that are present because we weren't able to. So we're dumping all of this money into factory overhead for variances because we didn't give the manufacturing people enough time to do their job.
Right.
And my argument is, you can really hang a price tag on not delivering to manufacturing at the right time.
Right. And
you can use that price tag to make choices about how hard you're going to work to deliver on the right time. Are we going to end up doing risk buys of material even though we don't know whether we're really going to need it, because that will protect us from being late on things. So you can inform a lot of decisions. The cost delay is really a general purpose tool you can use for essentially any event that has the potential to be later than planned, and to say, do we have any information that would allow us to estimate the consequences, the financial consequences of being later than planned?
Is it consistent? I know it has been in our experience that once you get a sense of what the cost of delay, the pragmatic decisions about what to do to address those delays, often the decision you arrive at is seemingly counterintuitive from decisions you would have made had you not thought about cost of delay prior.
You're right, is that what you'll often find when you have a way of measuring the cost of delay,
right,
it ends up changing the way you look at a bunch of problems. Like, long ago I was working with a company that they were making these big, expensive machines. They were, sort of factory automation equipment and things. And they would build, it was expensive to build a prototype. It cost like $200,000 to build a prototype. So they would build a prototype, they'd use it as a beta unit, they would put it out on the customer site. And then the unit at the customer site would end up having a problem, and they try to fix it without going to see the customer, but sometimes they'd have to go to see the customer, they send the people down, they would fix the problem. And then, and the debug phase on the customer site took a lot longer than the debug would have taken in the factory
Right.
if they had the machine sitting in their lab. And so somebody said, well, look, why don't, instead of just building one of these prototype machines, why don't we build a twin
Yeah.
that we keep back at our own facility? Yeah, it costs us an extra
Another
$200,000, but it means we can troubleshoot the problems much faster. We can get that beta unit sort of accepted by the customer much faster in the process.
Get to market
It had
faster, yeah.
huge dividends in terms of being able to improve the process. But in a traditional mindset where you said, I'm only looking at the expenses, I'm not looking at the speed of my development process,
Right.
it had never occurred to anyone, why don't we build a twin of the beta unit so that we can do things cheaper and faster?
Is there a place in this whole discussion about cost of delay to assign and account for the opportunity costs of delay as well? One of the things we struggle
Yeah,
with
yeah.
is with finite engineering development resources. If I'm late a month, well, that is a month that I'm not extracting financial value from my client from. It's also a month that I cannot assign that engineering resource to another client's work that I can. So I typically find that if I have direct expenses of labor of $10,000, I'm actually exacting $20,000 of loss if I look at the opportunity cost as well. Is that valid, or am I being a little painting outside of the lines
I
there?
think it's dangerous.
Is it?
Yeah, the question has come up over the years. You're not the first person to ask it and
Right.
things like that. The problem is, and you'll see it, for example, in a similar conceptual case of where you have a platform product and derivatives based on the platform. And you say, well, the cost of delaying the platform is not just the platform, but it's all of the derivatives that are going to come from this. And the question becomes, okay, so then when we calculate the cost delay, should we include the children and the grandchildren
Yeah.
and the
Cost of delay
great-grandchildren
becomes infinite.
and
Yeah.
things like that? Now, in general, I don't recommend using the consequences on the other program.
Okay.
I recommend you take the other programs and view them as a separate decision of, is it cost effective for me to acquire resources to do those other programs? What is their cost of delay, and should I be expanding my engineering organization to do those other programs? I think it's better. It really can lead to, I think, bad decisions, because you can have something really great that is being blocked by something else. And in reality, your decision is, if you've got a really great thing that is being blocked, you probably ought to be starting that now.
Right.
You probably ought to be pulling resources off the not great thing so you
It's
can do
created the stall. Yeah.
do the really great thing, because otherwise the not so great thing ends up, directly delaying the great thing.